Hello everyone, let's look at the next problem. We have graph that represents the position of some object that moves in one dimension. Also we see the additional axis of time, and we see that graph is linear. As you all know that the slope of this linear function represents velocity, okay, which defined by delta x divided by delta t, or final position minus initial position divided by final time minus initial time. Now, with this specific problem, the final position, I will take this coordinate, but because that's what I have, that is what I was given as a data. Also, this coordinate, okay? Now, the final coordinate at time of half second, and the position would be 2 meters, okay, as you can see here. And the initial position would be at time of 0 seconds, when the position of the object is 4 meters, as you can see here. Then we calculate, okay, and we get that the slope or the velocity is minus 4 meters per second. You have to understand something. Those coordinates, we can call them like imaginary coordinates because physically you're not here, you're here at time of 0.5 seconds, okay? But this addition of this axis of time actually can help us to find linear function, okay, which is actually the position of this object at any given time. And this is what we're going to calculate now, or we will find this. We will use this equation, okay, because we know that velocity slash, we can say slope equals velocity, okay, and we see that velocity is constant because the slope is constant. Then I can use this following formula. Okay, we already found the velocity, which is minus 4 meters per second, and we need to choose which t0 and x0 we can use to find finally the expression of x of t. You can choose both, or you can choose this coordinate, or you can choose this coordinate. You'll get the same result. Let's look at the first choice, okay, which I am talking about this coordinate, 0 second, 4 meters. As we can see, we can substitute, okay, we'll substitute these values, these parameters with these values, okay. Now t0 is 0, as you can see here. Let's change the color, okay, but the position at this point of time is 4 meters. And the velocity, as I told before, we calculated, and the result was minus 4 meters per second. And the final expression for this linear function that represents the position of this object at any given time is given by this formula. Okay, now someone can again ask, we will get the same result if we use this coordinate? Let's check. Okay, let's substitute again those parameters with those values. Okay, then at time of 0.5 seconds, the position of this object is given, okay, with 2 meters. The velocity also, again, minus 4. Okay, let's go over mathematical steps, and we'll see that we get the same result. Okay, what can we ask now? We can ask when this object go through the origin? Well, actually, we're talking about this coordinate. When x of t equals to 0, and we need to find this time when it happens. Okay, then what we're going to use, we're going to use this expression for position that we found a few minutes ago. Now, instead of x of t, we will substitute this with value of 0 because this is the origin. Okay, 0 equals 4 minus 4t. Now, let's move this term of minus 4t to the left. Next step, we see this one, this expression. If we want to find time, we need to divide both sides by 4. And finally, we get this time of 1 second, which represents the position of object when the object itself is going through the origin of x, which means x of t equals 0. Okay, we can also calculate the displacement when we know that initial time is 1 second and final time is 4 seconds. The formula to calculate, or definition to calculate the displacement, is given by final position minus initial position. To calculate the final position at time of 4 seconds and to calculate the initial position of time of 1 second, again, we're going to use this expression that we calculated a few minutes ago. Okay, let's use the final time of 4 seconds. This way we can find the final position. Okay, when we substitute t with 4 seconds, we get the final position is minus 12 meters. And when we use the initial position, we will use, of course, the given time, the initial given time of 1 second. Okay, then we have the initial position of 4 minus 4, which is 0. And finally, we can substitute x2 and x1 or x final minus x initial with those values. Okay, and we get that displacement between those two times equal to minus 12 meters. Okay, at this point I'm gonna stop this video. I hope it helped you somehow, and we will see you at the next videos. Bye bye.